Welcome to my AllPrimes program. This is a program written in Java to test whether there are prime numbers in a given set of numbers passed through as an array, and it will identify which of those numbers are prime. So the first thing I did was first import the Java ArrayList utility because we will be using ArrayList in this program. Here is the class, AllPrimes. The main method is down below, which we will use later. But the first thing I did was to set up the first method to test a single number, whether it's prime or not. So it's called isPrime. It's a Boolean true false is what it's going to return. And we're going to pass through an integer as the parameter and call it number. So the main logic for this method is right here. We're using a for loop, and we're starting this counter variable I at 2 and counting up to 1 less than the number that we pass through it. If we pass through the number itself, it's going to be divisible by itself, and even if it's a prime number, since you can see later I'll explain this function that we're using to test, it's actually not going to identify as a prime number, so we don't want to test the number itself. So we're going to stop I at 1 less than the number. And we have to start the increment at 2, because if we start at 1, then any number that's divided by 1 is going to leave a remainder with this modulo of 0, and so it's going to not identify as a prime number in that case too. But the only thing is, because I has to be less than the number, we're not going to actually test 2 using this for loop, so we're going to have to handle that case in a minute, because 2 is in fact the first prime number. But we'll deal with that in a second. And first let's look at what function we're performing on our increment to test whether number is prime. So we're going to divide number by I and get the modulo remainder. And if there is no remainder, if it's equal to 0, that means that I is a divisor of the number, and it means that there is a divisor that exists other than 1, which we're not testing in the increment, or the number itself, which also, as we explained here, is excluded from our loop. And so if there is a number somewhere in there that gives us a remainder of 0, we know it has a divisor, and we know it's not a prime number, and we're going to return false for not a prime number in that case. And it's going to increment every single integer up into whatever number this is. So you can see, this program may not work for very large numbers, because it's going to have to increment so many numbers, and it might have a large big O processing time on this. But for demonstration purposes, for simple, relatively small numbers, this will accomplish what we want. Okay, so that's that. Now let's talk about the number 2 again. Since 2 is a prime number, we want to create a statement to handle that particular case. So we're going to say if the number is equal to 2, we're just going to go ahead and say it's true. It's a prime number. And if the number is less than 2, so if it's 1, or if somebody tries to pass a negative number or 0 through this, we're also just going to say that's false. Prime numbers have to be greater than 0, greater than 1. So there, we've handled negative numbers, 0 and 2. And then if this loop runs through every integer up to the number before number, and it's all false, then we're going to return true. So if it doesn't, if it doesn't return false, if it doesn't find false for any of those numbers, then it's going to end up returning true. It's going to be a prime number. Okay. Now we will try and test this single number prime number tester by first instantiating our class. Create an object, just call it PR, and it's a new AllPrimes object. And in order to test it, we're going to print AllPrimes, call the method isPrime that we discussed above, and pass through an integer. Let's try 14, which we know is not a prime number. It's divisible by 2 and 7. So let's see if we run this, what we get. We should get that this is false because it's not a prime number, right? And here we see that it is false. So great, our single number tester is working. But our ultimate goal is to be able to pass through a bunch of numbers and just pick out the primes. So the next step is to create a method for that. And here's what I made. I called this one only primes to only identify the prime numbers. And this time we're going to pass through an array of integers instead of just a single one. And we're going to call it numbers, the parameter of the array that we pass to it. And our return is going to be an array list that's just going to populate with however many primes we find. Okay, and we're also going to be incrementing on this. So what we're going to increment, okay, first we're going to create an array list called primes as a new array list. Okay, and then for each number, we are going to test the numbers array that we will declare below in our main method. Okay, so it's going to pass through the numbers array and increment every number and determine whether it's prime. Okay, so here's our if statement. If the number, and here we're calling our first method is prime again. If the number is prime, if we get a true statement for this if statement, then we're going to add that number to the primes array list that we're creating here. Okay, and here's the return. We're going to return that array list. Okay, and so we're going to increment through every number and test every number in the numbers array. Okay, so hopefully that will work when we define and declare an array and pass it through. So let's do that in our main method. Here's the numbers array, and I've just picked a list of numbers, some primes, some not. And then in order to test it, we're going to print out what we get when we call our only primes method on the object that we created with the numbers parameter passed. Okay, so let's run it. And one note here, we didn't do a constructor because we're not going to give any attributes to the single object that we created. So we're just going to allow Java to handle that construction of our object. And here we go. Here's our result. So let's see what we got. It identified 29, 11, 101, 43, and 89 within our array list. And those are, in fact, all prime numbers. And it didn't include 6, 28, 100, and and 100, which are even numbers and not prime. So it looks successful. Let's maybe try this by tweaking some of our parameters here. First, we'll try the single test, and we'll put in a prime number, 11. And see if we get true back here. Okay, so that's good. We've got true when we pass in through the single number 11. Let's try that number 2 that we had to handle individually and see if we get true for that one too. So yes, I properly identified 2 as a prime number. Okay, now let's take out maybe a couple of the numbers from our array here. We'll take out 29, and so hopefully it will not identify that one anymore. We'll go ahead and take out one of the non-prime numbers, 11, and so, sorry, 100. And so it should not show 29 anymore and still not show 100. So there we go. 29 is no longer among the primes identified, and 100 is still not there. So we can try to add another prime. Let's add, maybe add 13 here. and run that and see if we pick it up. Okay, there, now we've got 11, 13, and the rest of the primes that we already had. So it looks like it's working. Thank you.